Okay, assalamualaikum and very good morning. Today we're going to look on the next chapter of the computer graphic, which is input and interaction. So we're going to look in details what is input, what is interaction in the computer graphics world. So let me introduce to you with the Ivan research, which is it's point out that user sees an object on display, and then when the user sees the object, for example, we see an icon over there in our desktop. So we're going to click that. So when the user click or ourselves click the apps, so or touch the touch screen on the smartphone, so the object change, something like the object is ready to get open, okay, and repeat. So with the other application. So for example, we have so many physical device, keyboard, mouse that can act as an input when we press something, and then it process, and then it's become available on the screen. For example, we open the Microsoft Words, we go in it, we get ready to type something, and then we press the key there, and then we can begin to type the any kind of letters or words that we're going to be write on the screen on the Microsoft Word document. So there's example of the physical device such as mouse, trackball, light pen, iPad atau tablet, joystick and spacebar. Okay. So actually, what the input device is going to process is actually the location of the position of the point that we're going to click or touch. So this is an example: rotation of cylinders in mouse, roll of the trackball, and then some absolute position. Okay, sometimes it's really difficult to get very absolute, so they can just using some algorithm or calculation to calculate the prediction position, and also can get the variable very sensitive, so somehow the device might get accuracy issue. Okay, so the logical property is something like when we press something, they return a position and the object identifier, so what we're going to actually use. Okay, it seems similar like we use the C++ code where we use the C in to get an input, and then we produce an output with a C out. Okay, the other logical properties is something like the locator, return position, pick function, return ID of the object that we're going to pick, keyboard, stroke, evaluator, choice, and so on. There's so many things. Same thing with this one. Okay, for example, we have this input modes where the graphic server request something. Okay, let's see. Okay, the graphic server request something where they are going to print something. Look for the file first. Okay, and then pass to the print server. Same thing, we scan using the print server. Maybe we have scan version of the printer, and then we scan it, save it into file as temporary file, and then produce it on the workstation, for example. Okay, so input modes where it can be triggered by we click the mouse or we touch the touch screen on our smartphone. Okay, so when triggered, the input device return information to the system. Okay, so return the position, return what the code that we're going to process. So it seems like the trigger process, this is request mode, the trigger process is trigger, and then measure. Okay, and mode, maybe we have a trigger, process to trigger, and then queue up if there is some other event. Okay, so we need to queue up. So what is other event mode? Resize, export, and then for the mouse, click one or more buttons, multi-button, or multi-touch screen. Okay, motion, movement of the mouse, keyboard, press or release the key, hold or maybe hold the button of the key. So for example, if we play some games, so we need to hold that key for certain times and so on. Okay, so what is actually OpenGL have in their callbacks for this input, process, output stuff? Okay, so actually in OpenGL we have this common GLUT function, that display function, mouse function, keyboard, idle function, mouse function. So we're going to look on this GLUT callback. Okay, for the first one, the main loop. Main loop is actually where the program is in infinite event loop. We need to declare it. This is something like a very compulsory to the program if you are using OpenGL to have it. Okay, so we put the program into the infinite event loop. Okay, this is some sort of like event queue. For example, we have mouse event, keyboard event, display event, okay, and so on. So GLUT main loop some sort of like is trying to loop all the process, so we can actually, when something change happen, for example we press another button, so the object move in the computer graphic world. So GLUT main loop plays an important role of maintaining this change process. What about the GLUT display function? So GLUT display function, okay, for example when the Windows first is open, or when the window is reshaped, or when the Windows is exposed, and so on. There's so many things. So identify the function that need to be executed. So most probably the GLUT display function call the function of my display. The my display is actually where we put all our draw object stuff. So we might draw the object in another function, but my display function is where we call all the object that we need to draw, and if there any change, we put it here. Okay. What about the GLUT post to display? So GLUT checks to see if the flag is set at the end of the event loop. Okay, so for example, so this is the function. So GLUT display function is called whenever your window must be redrawn. This includes the time when one calls GLUT post to display. Okay, so GLUT post to display. For example, when does a window needs to be redrawn? When it starts change, it become visible, some part of it become visible, or when it moves. So example, you have a window at the first position, the window of your OpenGL might be here, but what happen if you use your mouse move it the window into this location? So somehow post display try to actually negotiate about this, and then move the display into this position, so it handles all this situation. Okay, so this is some, you might read this explanation from this person. Okay, what is actually the GLUT post to display? Okay, animating a display. Okay, so the first at all, you must clear all the window. So GL clear all the OpenGL program in my display, actually in my display function. For example, in this here, in my display function, okay, you must clear all the windows for any stuff that object being, and then we draw it again. When we call the GLUT main loop, we keep on redraw. So problem, the drawing of information in the frame buffer is decoupled from display of its content. So what is the solution? Instead of one color buffer, we use two, so that double buffer. So that's why we will look upon what is the meaning of the one color buffer or two color buffer. What is buffer? The buffer is some sort like when you have a memory, but you actually keep on change the lane of the memories carry the data. So when this, for example, we have a two lane, the first lane carry the first data, the second lane also carry the data. So it's some sort of like alternate switch between these two, so we can see actually the objects very clearly, and also it's not become flickering on the screen. Okay. Okay, so animating display. So GLUT init display mode. Okay, so you declare GL double. GL double is the double buffer. Okay, so in my display function, this is my display function. Okay, so you have GL color buffer bit. Is one you color. So you clear it, the screen, and then you draw the graphic here. This is where you draw the object, vertex, and so on. And then you declare the swap buffer because you're using a double. So swap buffer, you swap between the buffer. It's something like you queue up the event. Okay, so this is front buffer, this back buffer. So the first frame, you're going to see this front buffer, and then for the second screen, you're going to see this back buffer, and then the front buffer become the back buffer. So it alternates, something like this one. Okay, so this is if you're using GL flash. Okay, okay, so this the first buffer, and then this the second frame, and so on. So somehow you look continuously all the objects on the screen. Okay, this is where you get a double buffer. Okay, So we can see continuously the actually the object, okay, without any lag between it. Okay, so difference is between single buffer and double buffer. So you can, I have just through the internet. So when using the GS single, you can picture your code drawing directly to the display. When using GL double, you can picture having two buffers. Okay, one of them is always visible, the other one is not. So it's something at the back. Okay, you always render to the buffer that is not currently visible. When you're doing render buffer, you swap. That's why you're using the swap buffers. Okay, making the one you just rendered visible. So just because you have just rendered it previously, okay, you get it ready. So the one that was previously is now invisible, and you can use it for rendering the next frame. So it's somehow ready for the next frame. Okay, so the row of two buffer is reverse, alternate between each other. So this is another explanation for it. Okay, and then okay, next one we move to the GLUT idle function. So the idle callback is execute whenever there's no event, the event queue. So what happened if something like there's no change and no like input from the user and so on, but it have some minor change. For example, maybe we can have some incremental value for that object. Maybe the object has become bigger and bigger and bigger and so on. It's become increasingly large without any other input from the user. So this is idle function. It's used for the animation. Okay, and then continuously update. Okay, and then how to work on with the callbacks. This is some example with callback. How we going to call it all this callback. For example, GLUT more function, where we have a my mouse function. So make sure you declare in my mouse function, press left button, what going to do, press left button of the mouse, what it's going to do, and so on. Okay, so the positioning, say okay, OpenGL use a world coordinate system with the origin at the bottom left, so must invert Y coordinate and return by callback by the head of window. So somehow this is our head of the window, and then we return it. Okay, this origin the bottom left. So whenever you declare the object, the original position start with this one, and then it's move toward the up and right. Okay, so in order to terminating the program, we must put in our callback, for example in our keyboard function and mouse function, what button we're going to press it, and then it's the program will close down. But by default, you press escape, the program is going to shut down. Okay, okay, this is my mouse function. For example, we have some function, some example here. So if we press the right button and press it down, is it? If you press left button, okay, press left button, and then the state is GLUT down, which is we press it down, we can draw a square. So meaning this is where you draw a square at square, but you must press it down. So you press, and then somehow you can draw the square. Okay, so this is function of to draw the square. Okay, you can test it on your OpenGL program. And then we can draw the square or anything else, any else you want to draw continuously if your mouse button is pressed by using a motion callback. Okay, we can draw a square without pressing the button using a passive motion callback. So we can either just click once, and then you can just move your mouse and draw something without continuously press the button, or you can use it, or maybe you can use when you click it, the user must press it in order to draw something or to write something or so on. So it depends on your application. What about keyboard? Okay, keyboard is same thing. So we have so many key, either capital Q or lowercase q. It depends. Okay, we can either use the caps locks, or maybe we can put both function, either capital or lowercase. So when we press Q, the program will exit. Okay, it depends. What about special modifier keys? Okay, we have key F1, key up. Okay, this is mostly if you try to create a game, okay, using OpenGL. Okay, so there's many things we can look for this command. What about the reshape function? Okay, so must be redrawn from the application. There's two possibility: display part of the world, display world, but force it to fit a new window, can alter the display. So reshape function is the one that's important element. It's where you handle something like this one. Okay, For example, we have original, this is what we intend, but if the user try to stretch the window and so on, it's something is become like this. So maybe you need to consider it, either to follow the width of the windows, or actually you declare some width and height proportion to the object. Okay, this is very important. So in OpenGL, we most probably we look upon this function. So GLUT reshape function, we call it in the main function, and then in my reshape function, which is this one, void my reshape, is where we declare our reshape function. Okay, for example, this one, this is example. Okay, I have put in the lab sheet. Okay, so we declare GL viewport. This is where our view, where we going to look on the screen. GL Animating modes is our projection. Okay, where is going to look, the volume that going to look, load entity, reset the screen. And then this is if we are using GL auto, this is one is actually we going to make the window proportion to the object, so we can have the object very nicely draw when we change the size of the window, move the window and so on. And then call it back GL Animating mode to GL model view. So we going to return it to the model view mode. This is where we actually see the object in original proportion. Okay, this is some toolkit that also come along with the OpenGL. Okay, so you can install it or put this additional library on the OpenGL, but I haven't used it for a long time, I think. Okay, this is defining a simple menu. Okay, we create the menu. Okay, so this is how we put something like have a menu on our Microsoft Word, Microsoft Office, where we can click file, exit and so on. Okay, but luckily we currently for the today technology and today advanced software such as Visual Studio, we can actually use the predefined button and also main menu that we can use. And then what we need to do is just to actually code some OpenGL function. Okay, this is menu action for the callback, void main menu. For example, we have the clear, this one is for the glue function also. Okay, the glue. Okay, we call it a glue. This one, glue. See, so actually we can glue.h. So you need to find this library along together with the DLL file. Okay, the other function of the OpenGL in GLUT. Okay, we can have the dynamic windows, we can have multiple windows, sub windows, and same windows we can have some mini display. It's like that you play some games and then you can have a mini map over there. Changing the callback during execution. Okay, we can have a timer, we can use some portable fonts and so on. So there's a lot of stuff you can use by using OpenGL. Of course, the OpenGL technology has actually become slower right now because of the introduction of the other graphic library that advanced, and also the uses of the game engine such as Unity and Unreal. Okay, you actually can create game not just using OpenGL. You can just directly drag and drop using Unity and Unreal and just put some snippet code for the object to work. Okay, compared to the OpenGL, you need to actually define everything over there. Okay, but in order to create the game engine itself, okay, you need to code, okay, in C++, either in C++ or using any other tools. Okay, so it's still important to know what is the basic, the fundamental of the graphics. All the software is come from the programming language. Okay, you either write it in C++, in C, in Java, and so many other things, and then you create a software, and then that software is going to be used by other people to create their games, their apps in the much more simpler compared to us that actually we develop that tools. Okay, so that is the challenges for the programmers, especially for the developer that create a tools for other person to use that tool to create another tools. Okay. tools create tools. Okay, so that's it for today. If you have any other question, just WhatsApp me via our WhatsApp group. Okay, and for other people out there in the public, so thank you for watching this, and hopefully you guys can write some comment if you like. So thank you and have a nice day. Bye.